A video that looks perfectly smooth to you can look like a visible strobe light to the tiny animal hovering next to your screen. Your room may look calm, while something beside you sees it flashing. The strange part is not just faster reactions. Some animals seem to split the present into more pieces than you do. We can measure that with one simple question. How many light pulses per second still look separate before they blur into one steady glow? Humans hit that limit pretty early. Once a light blinks fast enough, it turns into a steady glow. Go past that, and a screen, a ceiling light, or even your own hand can stop looking smooth at all. Songbirds get past your limit much faster than you'd guess. Not eagles, not some jungle monster, little garden birds. In 2016, blue tits, colored flycatchers, and pied flycatchers still saw daylight flicker at 131, 141, and 146 hertz. To you, that already looks steady. To them, the pulses are still there. The job explains why. You're a small bird in daylight, moving through branches after insects that jump sideways with no warning. A blurry update is bad. A late update is worse. So a yard light that looks steady to you may not be steady for the bird flying through it. Water does not slow this down as much as you'd think. Picture a snapping shrimp in a crack in the reef. Shadows keep shifting, fish keep darting past, and every useful movement is close and fast. In that mess, the shrimp Alpheus heterocales still reached at least 160 hertz, and some hit 200. That is the highest ever measured in any aquatic animal. Even in murky water, its eyes update fast enough to catch motion that a slower eye would blur. The point is simple. Fast visual timing is not just for birds chasing things through open air. If missing one tiny movement costs you, evolution keeps paying for speed. Two ants make that really obvious. Myrmecia ants that hunt by day reached about 189 hertz in bright light. Close relatives that hunt at night topped out near 125. In darkness, the night ants held up better. In glare, the daytime ants pulled ahead. So this is not one ladder with humans somewhere near the top. Vision gets tuned to the kind of light you work in. Noon rewards speed. Dusk rewards getting more light out of the same scene. Even one animal is not stuck at one setting all day. Light level changes the threshold, time of day changes it too, metabolism changes it as well. Many LEDs and fluorescent lights pulse around 100 to 120 hertz. You do not see that at all. Fast birds, fast insects, and some other outliers absolutely can. So a room that feels still to you may be full of visual noise to them. Very rude lighting, honestly. Now look at how wide the range is across animals. The beetle Melanophila acuminata lands between 300 and 500 hertz. That is hundreds of visible light changes every second. A giant African land snail sits around 0.57 hertz, which is about one visual update every 2 seconds. Put those side by side, and the scale gets ridiculous. One animal catches change extremely slowly. Another catches it so fast that your version of smooth motion starts falling apart. That also kills the lazy idea that better vision means one simple upgrade. A fly is not seeing a prettier world than you. It is seeing change on a faster schedule. Now think about the tiny fly near your monitor. Fruit flies have compound eyes with wide gaps between the facets. On paper, that sounds terrible for detail. The surprise is that detail is not the whole game. Reset speed matters just as much. The main motion cells in a fruit fly recover absurdly fast. That lets the fly refresh the scene before the last one blurs into the next. Those cells also make tiny mechanical shifts while they work. So when something moves across that rough grid, the signal stays clean enough to keep updating instead of turning into mush. That is why the screen example is real, not just a neat comparison. A monitor that looks completely steady to you can break into obvious flashing for an insect with a much faster visual clock. The same goes for pulses from artificial lights, and for your hand moving past them. What feels like one clean sweep to you may reach the fly as separate positions. Then houseflies take the whole thing into rude territory. This is the animal everybody has missed with a lazy swat. There is a reason, and yes, it is insulting. When a housefly moves, vision should get worse right when the movement starts. The image should lag and detail should wash out. Instead, the link between its photoreceptors and the next neurons can switch into a much faster mode during saccade-like motion. The effective bandwidth reaches roughly 1,000 Hz. The wild part is when that happens. The system speeds up exactly when motion should wreck the picture. So the fly's visual system changes gears in the middle of movement, and the world stays current while its body whips around. Behavior stays fast too. Houseflies still make accurate responses in about 13 to 20 milliseconds. So the signal is not just hitting the eye quickly. It's turning into action before the light response has fully peaked. That is the clearest extreme here. Not just a high flicker threshold, a visual system built so fast that motion does not get much chance to turn into blur. So if you've ever waved at a fly and thought it had supernatural reflexes, the rude answer is simpler. Your hand arrived as one smooth gesture to you. To the fly, it may have been a long warning, broken into obvious steps. One honest note before the close. Critical flicker fusion is a great hard measure for this subject, but it's still just a measure. It tells you how finely an animal can detect visual change. It doesn't let you climb inside the animal and feel what those extra slices are like from the inside. So the measurement is solid. The inner experience is still an inference. Still, the pattern is hard to ignore. Birds catch pulses your eyes miss. Shrimp do it underwater. Ants split apart by daylight and dusk. Flies speed up their own visual machinery during motion. The next time a fly hangs in front of your screen or a bird cuts through your yard, remember this. The room is not one room. The present is not one present. Smooth motion is not a universal fact. For you, the world flows. For them, it may flicker. That is why time is far less shared than it feels.